There's a place on Earth where the sun disappears for months at a time, where the wind moves fast enough to strip skin from bone, where the temperature falls so low that breath freezes before it leaves a body. Most living things flee from a place like this. Almost nothing on the planet is built to survive it. And yet every single year, as the last light fades and the ice begins its slow and merciless expansion, something extraordinary happens. Thousands of animals turn away from the safety of open water and start walking directly into the coldest, darkest, most violent winter on the surface of the earth. They are not lost. They are not confused. They are choosing this. And by the time you understand why, you will never look at these creatures the same way again. This is Fawad's Deep Blue, and today we are stepping into one of the strangest survival stories in the natural world, a story that unfolds in near total darkness, in temperatures that can fall below minus 60 degrees Celsius, in winds strong enough to flatten a grown man. It is the story of the emperor penguin and the impossible winter march that defines his entire existence. Let's begin where the story begins for them, not in summer, when Antarctica is merely brutal, but in autumn, when it starts to become something else entirely. As the days shorten across the Antarctic coastline, the sea ice that has spent months breaking and drifting begins to thicken and lock together. Temperatures that once hovered near freezing start their long fall toward the incomprehensible. The sun, which never fully sets in the Antarctic summer, begins to dip lower each day until, eventually, it stops rising altogether. For the next several months, large parts of this continent will exist in near total darkness. This is when almost every animal capable of leaving does exactly that. Seals retreat to open water. Skuas and petrels take the sky and abandon the interior entirely. The Antarctic coast, already one of the most hostile environments on the planet, becomes something closer to another world. And this is precisely the moment when emperor penguins begin walking inland, not toward food, not toward warmth, away from both. To understand why, you have to understand what they're walking toward: a breeding ground. Emperor penguins are the only warm-blooded animal on Earth that breeds during the depths of the Antarctic winter, out on the sea ice itself, often 50 to 100 kilometers from the open ocean, where their food actually lives. Scientists have asked for decades why an animal would evolve to do something that seems as reckless. Why not breed in summer, like almost every other species on the continent? The answer, as strange as it sounds, is timing. A penguin chick takes months to hatch and grow large enough to survive on its own. If the parents waited until the relatively mild summer to begin breeding, the chicks would still be small, defenseless, and unable to swim by the time the brutal winter arrived again. So evolution pushed the emperor penguin's breeding cycle backward, into the very heart of the cold, so that by the time summer finally does return, the chicks are just old enough to enter the water and fend for themselves. It is a bet against nature's harshest season, made so that the payoff arrives exactly when it's needed. But it is a bet that comes at an extraordinary cost, one paid for in flesh, fat, and sometimes in lives. The walk itself is almost hard to picture. Groups of emperor penguins, sometimes numbering in the thousands, form long single-file lines across the ice, trudging for days through featureless white terrain with no landmarks, no shelter, and temperatures already plunging toward lethal. There are no trees to break the wind, no burrows to hide in, just open ice and a horizon that looks the same in every direction. And still, they walk in the right direction, arriving with astonishing consistency at the same traditional breeding sites their species has used for generations. How they navigate this landscape with such precision remains only partly understood. Some researchers believe they may use the position of the sun low on the horizon or subtle visual cues in the ice and mountains to orient themselves. Others suspect an instinctive pull that current science hasn't fully mapped. Scientists still don't know exactly how an animal walking through a nearly featureless white void manages to find its way to the same patch of ice year after year. What we do know is that whatever internal compass they're using, it rarely fails them. Once they arrive at the breeding colony, courtship begins almost immediately because there is no time to lose. Males and females pair off, and eggs are laid within weeks. And this is where the story takes its first truly alien turn. The female, having used most of her body's reserves to produce a single egg, transfers it to the male's feet in a careful, practiced motion, and then leaves. She turns and walks back toward the distant ocean to feed, sometimes journeying 100 kilometers each way. Because she has nothing left to give, what happens next falls entirely on the male. And what he does next is one of the most extreme acts of endurance in the animal kingdom. The male emperor penguin will hold that single egg balance on top of his feet, tucked beneath a fold of warm skin called a brood pouch, for roughly 2 months. He will not eat during this time. He will not leave. He will stand in the open, through the polar night, through blizzards, through temperatures that can fall below minus 60 degrees Celsius, through winds exceeding 150 kilometers per hour, doing nothing but protecting that egg from the ground and from the cold. If he drops it, even for a few seconds, the egg can freeze and die almost instantly. So for 2 months in total darkness, he simply does not put it down. To survive this, thousands of males will crowd together into what is now one of the most famous behaviors in the natural world, the huddle. Picture a mass of animals packed shoulder to shoulder, so tightly that from above it looks like a single, slowly shifting organism rather than thousands of individuals. This isn't a static formation. It moves in a slow, rolling rotation, with penguins on the freezing outer edge gradually shuffling their way toward the warmer center, while those who've had their turn in the core drift back out toward the wind. Researchers using thermal cameras have found that the core of a huddle can be dramatically warmer than the surrounding air, sometimes reaching temperatures more typical of a mild day than an Antarctic blizzard, even while the penguins on the outer rim are being blasted by lethal wind chill just meters away. It is, in effect, a living furnace built entirely from cooperation, a survival mechanism so effective that no individual penguin could reproduce its warmth alone. What's strange is how orderly this chaos actually is. You would expect thousands of animals crammed together in the dark, in agony from the cold, to devolve into a fight for the warmest spot. Instead, the rotation appears to follow something close to fairness, an unspoken system that shares the worst of the exposure across the group over time. Scientists have studied the mechanics of these huddles for years, modeling them almost like the movement of fluid or granular material, and they found the behavior is more complex and more efficient than a simple crowd of bodies would predict. But there's a deeper question sitting underneath the data. This behavior only works if the individual penguin is willing to sacrifice comfort for the group again and again for months in the dark without any of the social signaling we associate with cooperation in other animals. What compels an isolated, food-deprived, sight-limited creature to hold its position in a rotating mass of thousands rather than break off and try to survive alone? This raises a larger question that goes beyond penguins entirely, about how cooperation emerges in species without complex language, and how it becomes so deeply wired into a behavior that failure to cooperate would very likely mean death. While the huddle protects against the wind and the worst of the temperature, it doesn't protect against the deeper problem facing every male in that mass, the fact that he has not eaten in months. By the time an egg hatches, a male emperor penguin may have lost close to half of his original body weight. He survives entirely off fat reserves built up before the breeding season began, essentially fasting through one of the most extreme metabolic demands imaginable, for well over 100 days if you count the walk-in, the incubation, and the walk back. To manage this, his body does something that still fascinates physiologists. His metabolism slows. His heart rate drops. Non-essential systems are throttled down to the bare minimum required to stay alive, all while his body continues generating enough heat to protect the egg. It is a form of controlled, partial hibernation happening inside an animal that is still standing upright, still exposed to the open air, still actively parenting. There is no den, no burrow, no shelter from the storm except the bodies of thousands of other starving animals standing just as still, just as exposed, just as committed. And then, somewhere in the darkest stretch of the Antarctic winter, the egg begins to hatch. If the timing goes wrong, if the female is delayed on her long walk back from the sea, the male faces an agonizing biological trade-off. His body has one final reserve to draw from, a substance secreted from the lining of his esophagus, sometimes described as a kind of crop milk, which he can feed to a newly hatched chick for a short time even though he himself has eaten nothing in months. It buys the chick days, not weeks. It is, in effect, a father giving away the last of himself in liquid form, hoping his mate returns before that final reserve runs out. When she does return, usually recognizing her partner and her chick's specific call among a crowd of thousands of nearly identical animals through voice alone. The exchange is almost businesslike in its urgency. She takes over the care of the chick. The male, now emaciated, sometimes barely able to walk, finally turns toward the distant ocean to feed for the first time in months. The ability of two specific individuals to find each other by sound in a screaming, freezing crowd of thousands in complete darkness remains something researchers are still working to fully understand. Each penguin's call carries subtle, unique characteristics, something closer to a vocal fingerprint than a generic cry, and both parents and chicks appear to memorize these calls with remarkable precision. But how a brain this size manages to isolate one specific voice inside an enormous wall of near-identical noise in the dark under extreme cold stress is a question that continues to draw scientific attention. What we discovered only deepens a mystery, because the same acoustic feat is somehow repeated reliably across an entire colony, thousands of times, every single season. From here, the story shifts from endurance to growth. As the chick develops, both parents begin alternating trips to the sea, taking turns feeding, walking the long trek back and forth across ice that is only just beginning to loosen its grip as the polar night finally starts to release. Chicks huddle together in groups of their own, sometimes called creches, packing together for warmth and miniature versions of the same behavior their fathers performed to protect them before they even existed. It is, in a strange way, an inherited survival technique passed down not through instruction, but through instinct alone, appearing fully formed in animals that have never been taught to do it. But even now, danger has not disappeared. Predators patrol the edges of the colony and the surrounding ice. Storms can still kill exposed or weakened chicks. And the single greatest threat of all remains the ice itself. Emperor penguins depend on the sea ice staying stable and intact for long enough that their chicks can grow waterproof feathers and reach a size where they can finally survive in open water. If the ice breaks up too early, chicks that aren't ready can be swept into freezing seas before they're able to swim, an outcome that is almost always fatal. In recent years, researchers studying colonies along parts of the Antarctic coastline have documented seasons where early ice breakup led to catastrophic chick losses across entire colonies in a single event. This is where the story of the emperor penguin quietly becomes a story about something larger than one species, because the timing of that ice, the very foundation this entire reproductive strategy depends on, is changing. Scientists still don't fully know how resilient this species will be if the pattern of the ice becomes less predictable than the ancient rhythm their biology was built around. Eventually, if all goes well, summer light finally returns to the far south. The remaining sea ice begins to break apart, and the chicks, now covered in the beginnings of true waterproof feathers rather than their fluffy juvenile down, finally take to the water for the first time. It is a culmination of everything that came before: the walk into darkness, the standing fast through impossible cold, the fasting, the huddling, the delicate handoffs between exhausted parents, all of it converging on this single moment where a young penguin enters the ocean it was always destined for, months after his father first balanced his egg on his feet in the freezing dark. When you step back from the individual details, what remains is something almost impossible to categorize using ordinary language. This is an animal that evolved to treat the deadliest conditions on the surface of our planet, not as an obstacle to survival, but as a required stage in it. Every adaptation, the huddling, the fasting, the delayed metabolism, the vocal recognition, the precise navigation across featureless ice, exists because the species didn't retreat from Antarctica's winter. It built its entire life cycle around walking directly into it. And still, so much remains unexplained. We don't fully understand the exact mechanism behind their navigation across the ice. We don't fully understand how their brains isolate a single voice from thousands of others in a freezing, screaming crowd. We don't fully understand the precise threshold at which cooperation inside a huddle would break down, or why it so rarely does. And we don't yet know how this fragile, astonishing strategy will hold up as the ice it depends on becomes less certain with each passing decade. Antarctica remains one of the least understood environments on Earth, a landscape that still keeps most of its secrets locked beneath ice and darkness for the majority of the year. The emperor penguin is one of the very few creatures that has learned to live inside that secret, walking toward it every single year, while nearly everything else on the continent walks away. Somewhere out on that ice right now, in the middle of a winter darker and colder than almost anywhere else on the planet, that same walk is happening again. Thousands of animals moving in a slow line across an empty white horizon, choosing once more to freeze into Antarctica's deadliest winter, for reasons we understand only in part, and for a payoff that remains, in the truest sense, a matter of life and death. If this journey into one of the coldest places on Earth pulled you in, make sure to like this video, subscribe to Fawad's Deep Blue, and leave a comment below telling us which part of the Emperor Penguin story surprised you the most. There is so much more of this planet's hidden world still waiting to be uncovered, and we'll keep going deeper, one story at a time.